So good morning. I'm Dr. Vijayalakshmi, Professor Department of AI&DS. So we'll be seeing the topic process under operating system foundations. So in this presentation, we'll be seeing about process. What is a process? What is process concept? What are the process states? And what are the different process scheduling methods? So first we'll see what is a process. So usually programs are stored in the hard disk, different variety of programs like Word document or Java program or C program like that. So once when a program, if you want to execute it, once when it is brought to the main memory, it will be called as a process. That is, a process means a program in execution. So process will be executed in a sequential fashion. So no parallel execution of instructions of a single process is allowed. So if you take a process, multiple paths are there. So the main coding program code will be there, that will be called as text section, and then a program counter will be there, process registers will be there, stack is there. So stack is a memory location which is going to store temporary data, and then many function parameters, return address, local variables, etc. will be stored in the stack. And then data section will be there, which contains global variables which are used by the program. Then the next part is heap, which is used for dynamic allocation of memory when it is requested by the process. So usually the program will be called as a passive entity which is stored in the hard disk. So once it is brought to the main memory, the process becomes active. So process will be called as an active entity, but program will be called as a passive entity. So program becomes process when an executable file is loaded inside the memory. So execution of the program started via mouse click or command line entry. So different ways are there. You can execute a process or program. So one program can have several processes. So in a particular program itself, multiple processes can be there. So this is what is given in the diagrammatic representation. So in the memory, we have text, that is a coding in one end of the memory. Then we have the data, which is going to be used by the process in one section. Next we have the heap, which is for dynamic memory allocation, and then the stack, which is used for storing function parameters, etc. So this will be the arrangement of process inside the memory. So when you take a process, in its lifetime, it will be in any one of the 5 states. So the different states a process can be is new state or running, waiting, ready or terminated state. So what do you mean by newborn state is, just now we have created a process. So then it is called as a newborn state before its execution state. Next, once it is allocated to the CPU or processor, it will be starting its execution. So that state of the process will be called as a running state. So once inside the process, if some IO request comes, means the process will be brought to waiting state. Then next, after that IO is completed, once again the process will be put back in the ready queue, or just it will be waiting for the processor to get executed. So that state will be called as ready state. So once a process completes its execution, it will be leaving the system. So and it will be moving to dead state or terminated state. So these are the 5 states. If you take for each and every process, it can be in a lifetime. So the same thing is given in the diagrammatic representation like this. So first, in the newborn state, a process has been created, whatever resources is needed for that process has been assigned. So now it will be waiting, it has been created now. Next it will be going to the ready state, that is, it will be queue will be there. So there it will be, all the process will be standing in a queue waiting for the CPU next. So it will be that process called as admitted. Then next, from ready state, it will be going to a running state. So that running state means it will get the CPU for execution and it starts its execution. So from running state, it can move to 3 different options. So first one is either it will complete it entirely and it will leave the system, then it will be moving to terminated state. Or else IO request has come, so from running state IO has to happen, then only it will can continue its execution. So at that time it will be brought to the waiting state. Then after completing IO, waiting state it will be going to the ready state. Meanwhile, while a process is running, sometimes external interrupt may come. So at that time, the process will be moving from the running state to ready state. And then next one is PCB, that is process control block. So whenever a process is created, for each and every process, a data structure called as PCB will be created and it will be maintained by the operating system. So what are the contents of the PCB is the status of the process. As I told, each and every process will be in its lifetime, it will be in any one of the state. So that state information will be maintained by the operating system. Next we have the program counter. So program counter is nothing but it is a pointer which points to each and every line of the coding, which is the next line to be executed. So that will be pointed by the program counter. So that information also is stored in the PCB. Next we have CPU registers. So registers will be there inside the processor, which is used for storing temporary data. So that data also will be what information is stored. So that will be also present in the PCB. Then CPU scheduling information, that is priorities, scheduling queue, pointers. So what is a priority of a process, whether it is having higher priority or lower priority for each and every process. So that information is also recorded in this. Then memory management information, what memory limit has been allocated for that particular process. Then accounting information, nothing but how long CPU is used since it's entered the processor and it left the processor. So that information is also maintained. Then IO status information, what are the IO devices which is held by this particular process, and if it is sometimes using some of the files, means what are the files which are being used or held by this process. So all this information will be stored in the PCB for each and every process. So once if the process completes and leaves the system, means this PCB will be deleted. This PCB will be usually stored in the memory. The next is process scheduling. So when the process, when it is moving to the ready queue, means many processes will be standing in the ready queue. So which process will next utilize a CPU? So that is based on a different algorithms called as process scheduling algorithm. So process scheduler selects among available process for next execution of CPU. So our goal is to maximize the CPU utilization. It should be maximum always. So that will be the goal of the operating system. So scheduling queues will be maintained, as I told. So two types of queue will be there. One is a ready queue, that is a process will be standing in a queue next to get executed by this processor. Next will be wait queue. So this wait queue is for IO devices. So many process will be waiting for IO request. So there a queue will be formed. So that queue will be called as a wait queue. And the processes can migrate between different queues based on their priority. So now we have the ready queue. So process standing in the ready queue. So from ready queue they will be either going to the CPU for execution. So once if it gets a CPU, it will move to the running state. Then from running state it can go to different states like this. So either IO request has come in that particular process, then it will be going to a waiting state. Process state will be in waiting state. So it will be put back in a IO queue. Then next IO will be getting completed. Then again it will be put back in the ready queue. Or else time slices expire. So each and every process will be given some time slice. So when the time slice is expired, means once again it will be removed from the CPU and it will be put back to the ready queue again. The next option is this current process, that is the parent process, has created a child process. So child process will get executed. Once a child process terminates, again it will be put back in the queue. The next one is if any interrupt comes, so that should be again handled. So interrupt comes, so once that is over, then again it will be put back in the ready queue. So this is how processes are scheduled based on the whatever event has happened. So once a process switching takes place, that is CPU is removed with one process and it loaded with another process, what happens is that process is called as context switch. What happens is the contents, the status of the process will be stored in the PCB, that is what is the contents of registers and what is the state of the process, etc. So as such it will be saved in the PCB, and then the new process will be loaded in the CPU. So that process PCB again will be loaded. So this process is called as context switch. So for each and every process changing or scheduling happening, this context switch will be happening between the process. So when CPU switches to another process, the system must save the state of the old process and load the saved state for the new process. So context of a process represented in the PCB, and it is a pure overhead. This is actually a time consuming process only for OS. The OS will not do any process during this context switching. The more complex the OS and the PCB, the longer the context switch. So the time taken by for this context switching will be more when the OS is complex. And again it is time dependent on the hardware. Whatever hardware we are using, it is dependent on that. Thank you.